let's try coming up with some formulas based off of some names of ionic compounds. So I have an example here, copper 2 acetate. So let's take a look at the next one, which is titanium 4 oxide. So titanium 4 means that our titanium has a 4 plus charge. So it has a 4 plus charge. Oxide always has a 2 minus charge. So I must have two oxides in order to balance out my titanium, which has a 4 plus charge. So this must be TiO2. If I look at potassium nitride, potassium always takes on a charge of +1 because it's an alkali metal. Nitride always has a charge of -3. Therefore, I must have 3 potassiums to balance out the charge of the nitride. Lead 4 sulfate, it's telling us in the name via the Roman numeral that the lead has a 4 plus charge. Sulfate is a polyatomic ion that you have to memorize. It has a charge of 2 minus, so it's SO4 2 minus. So if my lead is 4 plus, that means that I would need to have 2 SO4s or 2 sulfates to balance out that charge. So I'm going to write Pb, and then I will put my polyatomic ion sulfate. I'll put that in brackets like that to denote that there are 2 of them. The next one is ammonium hydroxide. There's 2 polyatomic ions in this compound. The first one is the ammonium ion, which has a +1 charge. The second one is hydroxide, which is OH minus, which has a -1 charge. So +1 and -1, they're going to come together in a 1-to-1 ratio to give us NH4OH. The next one, barium oxide. Barium is an alkaline earth, and it always has a +2 charge. It's in group number 2. Oxide, again, as we saw in the example of titanium 4 oxide, always has a charge of 2 minus. Just like the previous example, the charges balance each other out in a 1-to-1 ratio, so we just have BaO for barium oxide. The next one, calcium phosphate. Calcium is an alkaline earth. It has a charge of 2 plus. Phosphate is a polyatomic ion you must memorize, PO4 3 minus. It's a big one. So if you think about how would these two come together to balance the charge out, if I put them in a 1-to-1 ratio, then I would have an overall charge of -1 because +2 plus -3 would give you -1. So I'm going to need to have 3 calciums to give me a total charge of +6 because +2 times 3 gives you +6. And then I'm going to need 2 phosphates, so 2 PO4 3 minuses to balance that out to give me calcium phosphate. The next one, magnesium sulfate. So magnesium is also an alkaline earth with a charge of 2 plus. Sulfite, so if you remember, sulfate was SO4 2 minus. When I go from 8 to ite, I lose an oxygen, so it's going to be SO3 2 minus. And again, these balance each other out, +2 and -2, so I can just write MgSO3, so that's my magnesium sulfite. The next one, sodium bromide. So sodium is an alkali metal. It always takes on a charge of +1. Bromide, bromine is a halogen. It always takes on a charge of -1 to give us bromide. So they come together in 1-to-1 ratio to give us sodium bromide. The next one, copper 1 nitride. So if it's copper 1, and copper can take on 2 possible oxidation states, it can be copper 1 or copper 2, but copper 1 tells us that it's copper with a +1 charge. Nitrite, if you remember, nitrate is NO3 minus, so nitrite must be NO2 minus, like that. Again, they're going to balance each other out, +1 and -1 to give us CuNO2. And the last one is silver sulfide. Silver is a transition metal, but again, it's an exception like zinc or cadmium where it can only take on 1 possible oxidation number, and it's always silver +1. So it's always silver +1. And sulfide is always sulfur 2 minus. It always takes on the 2 minus charge. So I'm going to need to have 2 silver atoms, or 2 silver ions, to balance out the charge of the 2 minus from my sulfide. So this is going to give me Ag2S, like that. So I hope that gives you some a little bit of help in determining ionic compound formulas from their names.